And in today's episode, among other things, you'll see something that looks like science fiction, but is already happening. Scientists managed to connect human neurons to a silicon chip and taught those cells to play video games. We'll also see a new device about the size of a shoebox that's made of DNA and, in theory, could store all the world's data centers. Of course, we'll also have new robots, including robot dogs gaining industrial strength, and new humanoid robots. One of them is Xiaomi's, which is already assembling the company's cars by itself. Let's understand all of this. Hello, impressed viewers. I'm Carlos Salves, and you're watching Incredible Reality. An Australian startup called Cortical Labs announced that it managed to train about 200,000 human brain cells grown in a lab to interact with a classic game, Doom, which was originally released in 1993. These neurons were grown on a microelectrode array, thus forming a hybrid system between biology and electronics. The heart of the experiment is a chip called CERN-CL, one capable of converting digital data into electrical signals that the neurons can interpret. In practice, the system translates the game environment into electrical stimuli. The cells receive these signals, respond with neural activity, and the system converts this activity back into digital commands that control the character inside the game. The result is a completely new type of computing, where biological circuits become part of the processing. If you've followed Amazing Reality for a while, you know this isn't the first experiment like this. In 2021, for example, the same company had already managed to train lab-grown neurons to play Pong, the classic arcade game. At the time, more than 800,000 neurons were used and the training took over a year. But now, the progress has been even more impressive. With a new software interface, it took just 1 week for an independent developer to teach the neurons to navigate the three-dimensional environment of Doom. During the test, the cells were able to move the character and fire weapons. Inside the game, of course, it's still far from the performance of a human player. But the experiment revealed something very important. These biological systems demonstrated real-time adaptive learning, reacting to the environment and adjusting their responses as the game evolved. And this could have much bigger implications than just in video games. Researchers believe that hybrid biological computers could, in the future, help control robotic prosthetics, interpret complex signals from the human body, or solve problems that require a high degree of adaptability. Experiments like this show that the line between biology and technology is becoming increasingly blurred. But while some scientists are trying to turn neurons into computers, others are already going the opposite way. They are trying to turn machines into something more and more like us, human workers. Xiaomi revealed that it is already testing humanoid robots working directly there on the assembly line of its electric vehicle factory. In one of the tests released by the company, the robot was responsible for installing the self-tapping nuts on the structural floor of the vehicles, a task considered quite complex in the automotive industry. And the result caught people's attention. The humanoid managed to complete the process in just 76 seconds within the time required by the production line, and it maintained a success rate of about 90% during 3 consecutive hours of work. This type of operation requires extreme precision. The robot needs to pick up the nuts from an automatic feeding system, fastening points, and coordinate its movements with conveyor belts and automatic positioning systems. The challenge is not just tightening the component. The nuts have internal serrated structures. The positions vary slightly with each piece, and the magnetic force can interfere with the fitting. These factors significantly increase the complexity of the tasks. And to solve this, Xiaomi developed a system based on a vision language action artificial intelligence model. And this one has about 4.7 billion parameters. Does this type of model allow the robot to interpret the environment, understand the task, and perform coordinated movements using multiple sources of information, all at the same time? It combines data from computer vision, touch sensors, and joint position perception to understand what's happening around it. In addition, the system was trained with reinforcement learning in virtual simulations, where the robot faced hundreds of millions of simulated disturbances to learn how to maintain balance and precision, even in unexpected situations. The physical control mixes traditional optimization algorithms with this advanced learning, allowing the robot to react in less than 1 millisecond. According to Xiaomi, this is just the beginning. The company says it is already testing its humanoid robots in other stages of production, aiming to bring this type of technology to large-scale applications in automotive manufacturing. And when mobile robots start working inside factories, Some people are wondering what other types of machines will occupy other environments in our real world. One of these machines is this one. Take a look. The Chinese company Unitree Robotics announced the launch of a new type of quadruped, called the AS-2, a robot designed not just for technological demonstrations, but for real industrial tasks. And the specifications show exactly that intention. The robot was designed to carry up to 15 kilos of cargo, operate for more than 4 continuous hours, and travel more than 13 kilometers in a single mission. In addition, it has IP54 certification, which means it can work outdoors, even with dust, humidity, and light rain. In other words, it wasn't designed just for the lab. No, it was designed for our real world. It also has a maximum torque of 90 Nm at the joints, which allows it to maintain stability even when carrying tools, equipment, or sensors on uneven terrain. But maybe the most interesting detail here is in Unitree's strategy. The company announced that its robot will have an open platform for development, allowing companies and developers to adapt the system for different types of work. This means that the AS-2 can be used for industrial inspection, infrastructure monitoring, transporting tools at construction sites, security patrols, or even rescue operations. And of course, for military purposes as well. I have no doubt about that. There's another interesting detail in this competition. With a payload capacity of 15 kilogallons, this new robot from Unitree slightly surpasses the 14 kilo limit of the famous Spot from Boston Dynamics, one of the most well-known quadrupeds in the world. This kind of comparison shows that the race for industrial quadruped robots is becoming increasingly competitive. And Unitree's strategy seems pretty clear, doesn't it? Instead of selling a few extremely expensive robots, the company is now trying to make this technology more accessible and scalable for the market. If this happens, machines that today seem too advanced could become common in construction sites, factories, and logistics centers. And while robots are starting to gain ground in our physical world, another technological race is happening on a much smaller, almost invisible scale. Scientists are developing sensors capable of detecting subatomic particles with a level of precision never seen before. Let's take a look now at the technology that could help answer some of the biggest questions in modern physics. For quite some time now, the world's largest particle accelerators have been trying to answer one of the most profound questions in physics. What is the universe really made of? Well, to investigate this, scientists need to detect subatomic particles that are extremely rare and often invisible to traditional instruments. And now, a new type of quantum sensor could completely change this ability to observe. Researchers at Fermilab in the United States, in collaboration with scientists from National Aeronautics and Space Administration Caltech and the University of Geneva, conducted tests at Conseil Européen pour la Recherche Nucléaire with a new class of detectors called superconducting microwire sensors. These devices are known by the acronym Superconducting Microwire Single Photon Detector, and they were designed to detect individual particles with extremely high precision. In the most recent experiments, the sensors demonstrated the ability to identify high-energy particles, including electrons, protons, pions, and even muons, all with efficiency and time resolution superior to previous technologies. As a note, muons are subatomic particles about 200 times heavier than electrons, and their behavior can reveal important clues about the fundamental forces of nature. To improve the sensitivity of the sensors, the scientists used a thicker film of tungsten silicide, a superconducting material capable of better absorbing the energy of the particles that pass through the detector. And this small adjustment allowed the sensors to capture the events with greater precision, both in space and in time. And that's why some researchers are already describing these devices as 4D sensors, which are capable of recording not only where a particle was detected, but exactly when it passed through that detector. The sensors can also play a very important role in one of the greatest quests of modern science, the attempt to detect dark matter. This mysterious form of matter makes up about 85% of all the mass in the universe, but to this day, it has never been directly observed. According to the researchers involved in the project, the development of these sensors is still in its early stages, but the results obtained so far indicate that this technology could become one of the main tools in particle physics in the coming decades. And when we start exploring the universe on microscopic scales, we discover something quite curious. Nature itself already has extremely efficient systems for storing and processing information. Long before computers existed, life was already doing that. Pretty well, right? And now, scientists are trying to use exactly this mechanism to store digital data. The evolution of data storage has always followed the same path. Floppy disks became CDs, CDs became hard drives, And today, almost everything is stored in gigantic data centers spread across the planet. But some scientists believe that the future of information may be inside molecules. Researchers at the University of Missouri in the United States have announced the creation of the first DNA data storage system, which can be rewritten, working in a way similar to a digital hard drive. Yes, the idea may seem like something out of a science fiction movie, but you should know that the concept has existed since 1959, when physicist Richter Feynman suggested that information could be stored on a molecular scale. The reason is simple. DNA is one of the densest storage systems that exist in nature. While traditional computers use sequences of zeros and ones, DNA stores information using 4 chemical letters: A, C, G, and T. These are the bases that form the genetic code. And with that in mind, digital data can be converted into these molecular sequences. Researchers are able to store files inside synthetic DNA strands, and you should know that the capacity is quite impressive. In theory, all the data produced by humanity could fit inside a shoebox if it were stored in DNA. In addition, the material can remain stable for thousands of years when stored under proper conditions, consuming virtually zero energy. And that's an interesting contrast if we think about today's data centers, which require huge amounts of electricity to keep the servers running. The big problem until now was that this type of storage was permanent. After the data was written to the DNA, there was no way to edit it or reuse the molecule. In practice, this turned the system into a permanent archive, useful only for long-term storage. And it was exactly this limitation that the new research tried to solve. And they succeeded. The team developed a method that allows erasing and overwriting information stored in DNA, thus turning this biological medium into something similar to a rewritable hard drive. To retrieve the data, the researchers use a molecular sensor called a nanopore. When the DNA strand passes through this microscopic detector, it generates small electrical variations that are interpreted by the software. And all of this is converted again into chemical sequences of zeros and ones. And after this process, finally, into the original digital file. According to the scientists, the goal now is to miniaturize this entire system in the long term. They envision a molecular storage device the size of a flash drive. And if that happens, the impact will be enormous. Because instead of huge data centers consuming energy and taking up entire buildings, maybe in the future, our digital memories could be stored inside something much smaller, a molecule. This research shows that innovation doesn't always come only from big laboratories or research centers. Often, it arises when someone needs to solve a real problem, one that is specific to real life. And that's exactly what led to the development of an unexpected invention in the film industry. The Irish filmmaker, Christopher Link, he was born with osteogenesis imperfecta, a genetic condition known as brittle bone disease, which makes the bones extremely fragile and limits the ability to bear weight. He says he has suffered over 100 fractures in his life. Even so, he always wanted to work as a camera operator in the film industry, a profession known for requiring great physical effort, especially when using heavy filming equipment. But instead of giving up on his idea because of his problem, Link decided to create a solution. He created the Kairos Steadicam, considered the first camera stabilization system mounted directly on a wheelchair. The system was designed to work attached to the Genie Zero, a self-balancing wheelchair. It's capable of turning in very small spaces and reaching speeds of up to 20 km/h. This allows camera operators to perform complex movements without the need for tracks or additional equipment. The range reaches about 25 kilometers, allowing for continuous filming both indoors and outdoors. Another interesting detail is that all the weight of the camera and equipment is distributed across the structure of the chair. This eliminates the need for operators to carry heavy loads. And this doesn't just benefit people with disabilities, right? Operators without physical limitations can use the system to reduce fatigue during long recordings. The equipment can also be operated remotely or by camera assistants, in case the user needs to focus only on controlling the wheelchair. The result is a tool that expands inclusion in the audiovisual industry and at the same time opens up new creative possibilities for camera movements. And while some technologies are emerging to make human work more accessible, others are trying to create machines capable of interacting directly with us, human beings. And that's exactly what happened at one of the biggest technology events in the world, at the Mobile World Congress 2026 in Barcelona. A company decided to attract attention in a, let's say, different way. The Chinese manufacturer Honor took the stage and presented its first humanoid robot, and the demonstration was anything but discreet. The robot entered the stage alongside human dancers and performed a full choreography to the sound of the band Imagine Dragons. During the presentation, the machine performed synchronized movements with the artists, including a perfect moonwalk, the famous step made legendary by Michael Jackson. But a moment that really impressed the audience came. At the end, the robot performed a deadly backward punch, completely controlled, drawing applause from the audience before shaking hands with the Chief Executive Officer of Honor, James Lee. Although the presentation was impactful, the company hasn't released technical details, pricing, or availability for the robot yet. But the demonstration was part of a much bigger plan by the company. Honor revealed that it intends to expand its operations beyond smartphones and build a complete ecosystem of smart devices with built-in artificial intelligence. This project is part of the so-called Alpha Plan, a strategy that combines 3 pillars. The first is the Alpha Phone, a new device concept with artificial intelligence capable of physically interacting with the environment, or a robotic arm on the smartphone. This will be interesting to see. The second is Alpha Story, a platform where different smart devices can connect and share information. And the third pillar involves research into new hardware technologies, including advanced batteries, new materials, and robotics, of course. According to the company, the idea is to create what they call a silicon and carbon civilization, a future where machines, devices, and artificial intelligence will be working together as a single system. In other words, Honor wants to take artificial intelligence beyond screens. The idea is to turn software into physical machines that interact with the real world. If this vision really comes true, presentations like the one at the Mobile World Congress may be just the beginning of everything. Because the robots that appear on stage today to impress may tomorrow be walking, working, and living alongside us in our daily lives. If you enjoyed this episode, you know what to do. Right. Leave your like and make sure you're subscribed. Thank you for staying with me until now. Once again, thank you. Really, you have helped me a lot, and I'll see you in the next one. Just click on one of the 2 suggestions on your screen. Thank you for everything. All right, bye-bye. See you soon.